Have you ever wondered how a doctor can zero in on a rare disease? Or, how your email magically knows what's spam and what isn't? Well, the secret sauce is this really powerful idea called reasoning in reverse. And today, we're going to unpack this whole concept using, believe it or not, a simple puzzle with some colored balls.
So let's just frame the big question right up front. We're all pretty used to thinking about probability going forwards, right? Like, what are the chances that something will happen? But what if it's already happened? How can we use the evidence we have right now to sort of rewind and update our best guess about what led us here in the first place?
And don't worry, we're not going to start by throwing a bunch of scary formulas at you. Nope. Instead, we're going to use a classic puzzle, just a couple of bags and some colored balls. And I know it might seem almost too simple, but I promise, it's going to show us something really profound about how we can think more clearly in a world full of uncertainty.
Okay, let's dive right in. Here's the setup for our little thought experiment. It's pretty straightforward, but trust me, every little detail is going to matter.
All right, so here's what we're working with. We have two bags, bag 1 and bag 2. Simple. Each one has 5 balls inside, but the mix is different. Bag 1, you'll see, has a bit of an edge for red balls, 3 red and 2 black. Bag 2 is the exact opposite, 2 red and 3 black. And for right now, this is our entire universe, just these 2 bags. Now, before we get to the really juicy part, let's warm up with a more straightforward question. Imagine this. First, we choose one of the 2 bags completely at random. It's a 50-50 shot. Then we reach in without looking and pull out 1 ball. So, what's the total probability that the ball we end up with is red? To figure this out, we have to realize there are 2 different ways this can all play out. You could call them 2 paths to getting a red ball. Path number 1 is we happen to pick bag 1, and then we draw a red ball. Path number 2 is we pick bag 2, and then we draw a red ball. So let's just calculate the odds for each of these paths separately. Okay, let's break down path 1. First off, what's the chance we pick bag 1? Well, there are 2 bags, so it's 1/2, right? A 50% shot. Now, let's say we did pick bag 1. What's the chance of drawing a red ball from it? That's 3 out of 5. To get the total odds for this whole path, we just multiply those 2 chances together. That gives us a 3 in 10 probability. And now for path 2, the logic here is exactly the same. The chance of picking bag 2 is, again, 1/2, but this time the chance of pulling a red ball is only 2 out of 5. So we multiply those together, and that gives us a 2 in 10 chance for this second path. So what do we do with these 2 path probabilities? Well, since they're totally separate events, you can't pick both bags at the same time, right? We can find the total probability of getting a red ball simply by adding the probabilities of each path together. And that brings us to our first answer. 3/10 plus 2/10 gives us 5/10, which is a nice clean 50%. So if you were to do this experiment, you have a perfectly even chance of ending up with a red ball. Simple enough, right? Okay. But now for the twist. Let's completely change the story. We are no longer predicting what's going to happen. Instead, the experiment is already over. We've drawn a ball, we've looked at it, and now we have a crucial piece of new evidence. This right here is the key question. We are holding a red ball in our hand. We know this as a fact. So knowing this, what are the odds that the bag we originally picked was bag 2? See what we're doing? This is reasoning in reverse. We have the final outcome, and now we want to figure out the likelihood of the path that actually got us here. So, how in the world do we do this? Well, the tool that lets us perform this kind of logical magic is called Bayes' Theorem. You can think of it as a formal mathematical way to use new evidence to update what we thought we knew before. Now, I know the name might sound a little intimidating, but the core idea behind it is incredibly intuitive. All Bayes' theorem really does is give us a recipe for blending our old beliefs with new information to arrive at a smarter, more updated belief. It's how we turn our initial prior guess into a new posterior belief after we've seen the evidence. In fact, for our little puzzle, we can boil the entire theorem down to this very simple idea. The probability we're looking for is just a fraction. The top part is the probability of the specific scenario we're interested in, our desired path. And the bottom part is the total probability of the evidence we've actually seen. That's it. And you see, this is exactly why we did that calculation earlier. We already have both numbers we need. Our desired path is the one where we get a red ball specifically from bag 2, which we know has a probability of 2/10.
Our total evidence is just the overall chance of getting a red ball from either bag, which we found was 5/10. All we have to do now is divide one by the other.
And there it is. That's our answer. Given that we know the ball is red, the probability that it actually came from bag 2 is 2/10 divided by 5/10, which simplifies to 2/5 or 40%. Now think about that for a second. Our initial belief was 50%, an even chance. But now with this new piece of evidence, our updated belief has dropped to 40%. And why does that make sense? Well, because bag 1 had more red balls to begin with, making it a slightly more likely source for the red ball we're holding. So you might be thinking, okay, that's a neat little brain teaser, but what's the big deal? Well, it turns out that this exact same logic, this process of constantly updating our beliefs as we get new evidence, is one of the most powerful and important ideas in all of modern science and technology. This is so much more than just a thought experiment. This is the fundamental logic that powers your email's spam filter. That filter constantly updates its belief that an email is junk based on the words it sees. It's at the very heart of medical diagnosis, helping doctors update a diagnosis based on new test results. And it's an absolute cornerstone of artificial intelligence and machine learning, giving systems the incredible ability to learn from data. Really, at its core, this ability to reason in reverse is what lets us build systems that can learn and adapt on their own. It's basically a mathematical formula for common sense. So the next time you see a machine make a surprisingly smart prediction, just remember this little puzzle, because underneath all that complexity, it's probably just figuring out the odds of pulling a red ball from the right back.